Breast milk is amazing, but what exactly makes it so special? And why is it so much better than formula for the gut health of tiny humans?
What we see happening in formula milk is it contains a specific type of sugar for the infant. What tends to happen is those sugars feed a very different type of bacteria that can outcompete these beneficial bacteria.
But for some women, breastfeeding just isn't an option. That's why Dr. Sioned Jones and her team are working out exactly what nutrients and bacteria make up breast milk and how to replicate its benefits.
There is advancements being made. One of those advancements have been the inclusion of human milk oligosaccharides into formula milk. Up until now, it's been almost impossible to synthesize these human milk oligosaccharides at scale. But now, with some recent advancements in biotech, we're almost there.
Today, we learn about the side effects of poor gut health in infants, how a mother's own microbiome impacts her babies, whether adults should be heading to lactation bars to chug down shots of the stuff, and the new science of why pumping and storing breast milk can compromise its health benefits.
When there is air exposed to breast milk, these essential components like the microbiome, the anaerobic bacteria like bifidobacterium, they are completely destroyed.
I'm Dr. Karan, an NHS surgeon, and in this podcast, we cut through the BS of modern health advice and tackle the biggest issues in science, health, and medicine. Breast milk isn't just a source of essential nutrients for a baby, it also contains beneficial bacteria that kickstarts your baby's gut microbiome. It's thought that if all the UK infants were exclusively breastfed, tiny humans would be hospitalised for diarrhea half as much and would have to deal with far fewer respiratory illnesses. How is breast milk responsible for all of this, and what happens when you can't breastfeed? Dr. Sioned Jones is the co-founder of BoobyBiome, an all-female team of doctors uncovering the answers to these questions in the hopes of improving infant health. Enjoy the show and the breast milk chat.
I don't think it's very often that podcasts talk about breast milk. It's not something which is a common theme on podcasts, but in this case, I think breast milk is very, very interesting because it overlaps with one of my interests and curiosities, which is gut health. Maybe not for adults, but adults in the future, maybe. And breast milk is more and more we're understanding, as you'll definitely agree, as this wonderful customizable milkshake for tiny humans where it develops their gut, develops their brain, their immune system. But what is the science of that? What actually makes it so great?
So that's a great question. And breast milk really is a nutritional powerhouse to begin with. So it's packed with micronutrients. We're talking carbohydrates, proteins, fats, vitamins. And it's all perfectly balanced to meet the demands of that growing baby. And I find it so remarkable that breast milk is both dynamic and also personal to that individual. So if we just take carbohydrates, for instance, as adults, we'd get our carbs from glucose. Well, an infant will get theirs from lactose. But actually, in addition to that lactose, breast milk has what we call human milk oligosaccharides, or HMOs. And I actually love talking about HMOs because they've puzzled scientists for so long. They make up about 20% of the carbohydrates in milk, but we've never really understood them. And the reason is they arrive at the colon almost intact and the baby can't digest them. And it's only recently we've discovered that these HMOs act as a prebiotic to feed the bacteria in the infant gut. And so they can help produce short-chain fatty acids, help maintain the gut health of the infant, and inhibit harmful bacteria. But before I get excited talking about the microbiome, which I'm sure we'll get to, I should add that we've also got the proteins that have very specific functions. For example, lactoferrin can help with iron absorption. We've got the fat that's highly dynamic from person to person, depending on diets, but can also change depending on the time of day or even the feed itself. And so, whilst these components are very important nutritionally, it's really the bioactive components that gets me really excited as a scientist, because these are what's powerful against infections. So for example, you've got your immunoglobulins like IgA that can literally form a lining on the gut to prevent pathogens from coming in. We've also got, of course, the microbiome, which is this community of over 200 different types of bacteria that play so many different roles. And until early 2000s, we really didn't know that this bacteria existed. And so really breast milk, it's more than nutrition. It's really so many different factors coming together, which makes milk so much more than a food because it can give your infants the best start in life.
You've outlined there a number of things that breast milk contains, which makes it so complex, but also so important for infants growing and developing. On the flip side, this also makes it very challenging for us to create a breast milk substitute. I mean, we have infant formula, and I guess compared to decades ago, when infant formula was first manufactured, we've come a long way in terms of replicating the growth potential or the development potential of these sort of nutritional supplements for children. And I think we have come a long way, but it's still by no means achieved parity with breast milk. What do you see as the main challenges and differences between the current industry-leading infant formula and the average mother's breast milk?
That's a great question. And, I think it's important to start off by saying that formula milk has been a crucial alternative to parents who choose not to breastfeed or can't. And they provide these essential nutrients that I've spoken about, like the carbohydrates, the proteins that are required for infant growth and development. But they lack this microbiome. They lack these bioactive components. And as a result, we've seen how formula feeding can decrease the beneficial bacteria in your microbiome. It can increase the pathogens. And we've seen, such as in the news recently, that formula feeding can actually result in diseases like necrotizing enterocolitis and asthma and diabetes. But back to your question, there is advancements being made. And one of those advancements have been the inclusion of human milk oligosaccharides into formula milk. Now, only a very limited number of formula milk companies are doing this, and only in some countries of the world. And the reason for that is it's a very expensive process. Up until now, it's been almost impossible to synthesize these human milk oligosaccharides at scale. But now, with some recent advancements in biotech, we're almost there. But really the question is, are these major formula milk companies going to implement and put HMOs in all their products when they are already making billions and billions of pounds? And I'm going to refrain myself from commenting any further on that. But we are seeing advancements. And no, these will never be as good as breast milk because breast milk has hundreds of HMOs, but it's definitely an improvement. But what we can do to even better this is supply the bacteria as well. Because I mentioned earlier, what these HMOs do is feed a very specific type of bacteria in the gut. But if those bacteria aren't there in the first place, there's going to be a very limited benefit of using HMOs. And that's really where our research comes in and our future products come in.
So these standard infant formula mixes that are available out there, and like you said, some of them are starting to add these prebiotic fibers into the product itself, which is great. But I guess what you're saying is it's kind of like adding fertilizer to the soil, but not actually growing the flowers.
Exactly.
So why don't they add the flowers in the form of these live microbes, the probiotics? Because obviously in adults, probiotics work for a narrow range of conditions. But in an infant that has essentially an empty forest that's waiting to be seeded by bugs, it's probably thought that it's easier for live microbes that are given as supplements to take root because there aren't probably as many competing native bacteria that would prevent colonization of new added microbes. So why, if we're trying to achieve parity with breast milk, why isn't an industry standard to have probiotics? Like things like bifidobacterium, which is one of the most common types of probiotics seen in natural breast milk.
Exactly. And that's what we have been so frustrated about. And the reason for that is breast milk microbiome research has been completely underfunded and understudied. Up until 2019, where we set up BoobyBiome, no one had mapped the breast milk microbiome to strain level resolution. So no one had really understood what was living in there. And then in parallel to that, no one had isolated these strains and had characterized them at scale to understand the function of each strain. And what has happened is that we have a gap in understanding, which has led to a gap in innovation. And that's why we're not seeing any of these breast milk strains turning up in formula milk companies. I would say that we do have some infant probiotics out there, which is a source of bacteria for infants who are not breastfed. But none of these infant probiotic have strains isolated from the breast milk microbiome that's in a consortia to mimic what we see happening in that microbiome. And so, it's really difficult for babies to really have that full benefit of breast milk. But it really all comes down to a lack of research, a lack of funding. And that's exactly why we've spent the last 5 years really understanding what is happening here.
In terms of seeing the complexity of human breast milk, how is it actually manufactured on a microscopic level within the mother? What are the sequence of changes and triggers that happen in the mother that say, this is what the body needs to produce for this infant, or it needs to now change at this point in time? So how is it produced, number one, and then how is it constantly in flux to adapt to the growing infant's needs?
That's a great question. And it's a question I get asked all the time. Where do these breast milk bacteria come from? And there's no simple answer to that. Nobody really knows. A very interesting theory is that gut bacteria from the mother essentially gets translocated to the breast. And actually, there's a lot of studies and theory that backs this up. Because if you look at the gut microbiome of a woman during pregnancy, during that third trimester, her microbiome becomes more leaky, more permeable, almost dysbiotic. And what I mean by dysbiotic is there's an imbalance in that community of bacteria. And some people think that that's the body translocating the bacteria, preparing the mother for the transfer of the bacteria to the infant. So that's a really interesting theory. And a lot of our own research actually support that, where we've seen if a mother takes a strain of a probiotic, we often can pick that up in the breast milk, which is really interesting. And that just shows you how important things like diet is for mothers. Because there was actually a really cool study that looked at pre-gestation BMI of mothers and showed that women who are obese or overweight have less bifidobacterium in her gut, and in turn, less bifidobacterium in her milk.
Wow.
So that's really fascinating. But back to your question on why is this dynamic? How does it change? And it's a really good point to make, because your microbiome changes throughout the course of your breastfeeding journey, and it can also change from person to person. And there's a whole range of factors that can actually influence that. It could be your diet, it could be geography, it could be antibiotics, it could be the way that you've given birth. It could be how many pets you have in your house or how many siblings you have. And all these things influence the microbiome. But also this is a stepwise process. So think about your microbiome being assembled over time. You might have some strains coming in, creating a very specific type of environment for other strains to come in. And this is a sort of stepwise development up until the age of around 2 to 3 years old, where our gut becomes a lot more adult-like.
So I think it's really interesting that you mentioned there that this breast milk space, and especially analyzing the microbiome of the breast milk, is a very new science. And despite it being there for a while, it's only being looked at now. And I think it reflects the change in attitudes, or the slow change in attitudes of breast milk, because, if you read through the annals of history, even, as early as the 1950s, it was still seen, I guess, in certain upper classes of society as a taboo thing and almost like a task which was beneath them. Even if you look at the royal families, traditionally, they would have wet nurses to delegate the task to breastfeed their own children. And then, after that wave, and some research comes along that says that actually, no, breast milk is good. You then get the breast is best sort of phase where, I guess, yes, there's an increased understanding of breast milk is great, but I guess it also sort of lands a blame culture and alienates women who, for whatever physiological or psychological or physical reason, can't breastfeed. And then now we've obviously come full circle to understanding that any sort of nutrition and a fed state in a child is good. And now we can go into the nuance of breast milk and maybe try to manufacture new forms, of breast milk in labs using stem cells, which, may be something to look forward to in the future. But what I find really weird, the sort of newest tangent of this breast milk understanding and science, is in various places around the world, there are almost these gray areas or black markets where people are selling human adult breast milk. And it's particularly prevalent in Japan, where they've got vending machines selling human milk. They've got supposedly lactation bars where they also sell milk. I think you can buy a shot of breast milk for, dozens of dollars or whatever. And I'm just wondering, why are people doing this? And is there any benefit of breast milk to adults, given the rich nature of the nutrients it provides, probiotic value, and considering adults drink probiotics from supermarkets, would it not theoretically make sense that human breast milk would be beneficial to adults?
So that's a great question. And I think I'd start off by saying human breast milk, when we see it in, as you said, it's being sold online in quite an unregulated way, I imagine, which is quite worrying when we think about potential transmission of pathogens. But in some cases, this is being done in a much more regulated way by the means of milk banks, for example. And that's been a huge advancement, sharing donors' milk for infant health and, as you say, adult health as well. What I would say is, in that case, we are pasteurizing the milk. So we are heating it to a really, really high temperature. And in the process of doing that, we are destroying the microbiome. We are destroying a lot of the bioactive components as well. But that being said, there is a lot of studies that show that donor milk is better than formula milk. In fact, there was a really interesting study. This is done on infants. I'll get to adults later, where essentially it was looking at the impact of formula milk, donor milk, and breast milk on necrotizing enterocolitis. And you actually saw that, of course, breast milk, mother's own milk, was the best for reducing the severity of necrotizing enterocolitis. And then donor milk, and of course, formula milk was right at the bottom. And so, donor milk is a very exciting avenue to go into. I think it'd be great if we can find better ways to preserve these essential components a little bit better when we talk about the collection process, the processing, and the pasteurization. When it comes to using human milk for adults or any sort of probiotics for adults, I'm a little bit skeptical, and this is just my own opinion, especially when we talk about the microbiome itself. Because by the time you're an adult, your microbiome is already established. You've got hundreds and hundreds and hundreds of different bacteria that's living in your microbiome. And so will, a 1 to 3 probiotic or something like that, will that actually be able to have a huge impact on improving your microbiome? Personally, I haven't seen any clinical evidence that makes me feel confident of that. So I'm a little bit unsure. But, it's more than just the microbiome. We've also got these human milk oligosaccharides, and there's some really exciting studies showing the use of those now in clinical trials. And I think we'd expect to see them being used in sort of clinically validated products in the future. Probably not by selling online or in milk lactation bars, but, if they are done properly.
You mentioned some of these infant formula mixes have a potential to disrupt the microbiome of infants and cause, infants' microbiome to have less diversity in comparison to breast milk. What are some things that can happen to an infant, exposures and incidents that happen to infants, which can cause the microbiome to be disrupted or to be depleted, in sort of everyday life during that growth phase?
Yeah, so infancy is a really interesting one because it's a really critical period for setting up your microbiome, because essentially you're born as a blank slate. And so during early life, your microbiome is very malleable and it's very fragile. So correct seeding of it is really important. But as you said, there's so many things that can disrupt this. The first thing is, of course, is how you're born. So if you're born vaginally, you're exposed to maternal and the vaginal microbiome, which increases the diversity of your microbiome. If you're born by C-section, you miss out on that. And we've seen how there is an increase in skin bacteria or bacteria from the environment. Now, another factor is, of course, antibiotics, which is often intertwined with a C-section birth. And we've seen how antibiotics can deplete the diversity of the microbiome, but also increase antibiotic resistant strains. After those two factors, of course, your diet is the most obvious one. And I've already spoken about how, breast milk will increase the abundance of beneficial microbes like bifidobacterium, lactobacillus, whilst formula feeding won't. We've also got these HMOs in milk that will support the growth of the bifidobacterium. But then after that, there's things like gestational age, which brings in all of these factors. If you're born preterm, you're more likely to have antibiotics. You're less likely for your breast milk to come in. And that's when we see diseases like I've already mentioned, necrotizing enterocolitis, which is the leading cause of infant mortality in preterm infants.
So having this depleted microbiome obviously causes a number of these things like you mentioned, and I guess a rise in allergic diseases, autoimmune diseases. But what is it specifically, just drawing back onto the infant formula, what is it within the infant formula that can cause a disruption to the microbiome, as opposed to breast milk, rather than not doing any harm at all?
Yeah, so what we see happening in formula milk is it contains a specific type of sugar for the infant. What tends to happen is those sugars feed a very different type of bacteria that can outcompete these beneficial bacteria. So at the moment, these formulas don't have the HMOs to feed the bifidobacteria. They have other sugars. And so that's when we see these bifidobacterium being completely outcompeted. And that's something that we've definitely seen. And then, of course, it's the lack of fluctuation of bacteria. So that's essentially causing a more dysbiotic infant microbiome.
And I guess the microbiome, just as it is in adults, it's equally complex in infants as well, and maybe even more so because it's the early growth stages and I guess how it starts, the building blocks and the foundations of that for future life. Is there any crucial period in that first few months where I guess these things have to be avoided or limited as much as possible? For example, like you said, we know that chronic antibiotic use, especially in that early phase, can cause a later life increased incidence of allergies, autoimmune disease, and more. So is there a specific time frame in that time where you need to be more careful than ever about setting those building blocks for future life?
So we talk about this critical window, right? Or we talk about the first 1,000 days of life. But really, we don't know how long or short that critical window is. And that's what I find so interesting. What we've seen is that if you do things like breastfeed exclusively for 6 months, it can actually restore the microbiome and sort of reverse some of the damage that could have already been done by, for example, chronic antibiotic usage. The World Health Organization actually showed that if you exclusively breastfed for 6 months, it could reduce childhood obesity by 25%. So there was a study that revealed that children who were not breastfed while taking antibiotics had 3 times the risk of developing asthma by age 5 compared to those that were breastfed whilst taking antibiotics. And so we've seen that, we can restore and improve the damage that's been done, but we really don't know what that time frame looks like. Another example is we've seen how microbiome composition can be restored after a C-section. But there was a really interesting study that showed that babies born by C-section don't respond to vaccines as well. And that would indicate that that window of opportunity you're referring to is way shorter than that first 1,000 days of life that we've got from somewhere, I don't know where. And so we really need to follow the microbiome and have longitudinal studies so that we can create interventions that are a bit more targeted. And I think that could really help us moving forward.
And talking of windows, does the timing and length and duration of how long a mother breastfeeds has an impact? For example, culturally, there's a lot of variation in terms of how women breastfeed and how long for. In Guinea-Bissau, I think the average length of a mother feeding a baby is 22.6 months, which is considerably longer than in the Western world, where maybe in the UK, the average breastfeeding time might be 6 months. Is there any difference that you'd hypothesize in the microbiome richness, diversity, or makeup, depending on the length of time of breastfeeding beyond, say, 6 months?
So that 6 months is a really important time because up until 6 months, all that the baby receives is either breast milk or formula milk. And what we've seen is at the 6-point mark, often the baby starts to wean. So solid foods will be introduced. And that has a huge impact on microbiome diversity. And that's when it starts to become more adult-like. And so that first 6 months is definitely critical. But what we have seen is that a child's outcome in health is based on how long it is breastfed for. It also can be completely dose dependent in some scenarios. But it's really that first 6 months that sets the microbiome up. Because after that, as I said, it does become more diverse with solid foods being introduced, different types of sugars being introduced that can really change the microbiome composition.
So I guess that brings us nicely on to, we've spoken about the negative impacts on the microbiome based on breast milk and other factors. But now looking at, I guess, actionable strategies to improve it, is there anything a mother can do pre-pregnancy, mid-pregnancy, and immediately post-pregnancy beyond, optimizing, I think you said weight before that, having a significantly higher BMI can impact the, I guess, diversity and quality of the microbiome in the breast milk, but anything else factors-wise which a mother can optimize to optimize the microbiome in the breast milk?
First of all, when a woman is pregnant, she is facing so many stressful things that's going on. And I don't want to talk here about all the different things that you can do to improve your breast milk microbiome when it's already a really difficult time in life. Yes, of course, eat well, whole foods, balanced diet, all of those things is going to make you yourself healthier. That will prepare for your infant to be healthier as well. And really, yes, there are factors that can help, but really some of these are unavoidable. If a baby is born by C-section, that could save the life of both the mother and the baby. If a baby requires antibiotics, again, you could be saving lives here. And so my opinion on this is just sort of you do you look after yourself, and in turn, you'll be looking after your infant. If you can breastfeed, great. If you can't, there are solutions, and it's all about taking pressure off the parents, taking the guilt off, because it's already very difficult for those mothers, and that's kind of my stance on that.
Would any change in the diet to increase the proportion of fibers in the diet translate to positive changes in the breast milk as well?
Yes, definitely. We've seen there's lots of studies that look at the overlap between the gut microbiome of the mother and her breast milk microbiome, and also actually linking that as a triad to the infant microbiome. So actually, if a baby's born naturally, not on antibiotics and is breastfed, they'll actually share 72% of their gut bacteria with sort of maternal intestinal bacteria. And so if you can improve your own microbiome, you're definitely going to be improving your infant's microbiome as well. And things like diet, of course, can do that, as well as things like sleep and stress and no stress.
And I guess there's a lot of mothers who will breastfeed or at least pump the breast milk and then use it as bottle feed later on. Is there any change in the quality of the breast milk and microbiome specifically depending on the time of day? Is there an increase or decrease in the abundance of certain beneficial bacteria depending on the time of day it's pumped?
Yes, definitely. So we've seen how lots of components of breast milk can change depending on time of day, whether that's microbiome related, whether that's melatonin related, whether that's even fat related. But you mentioned pumping there, and that's actually something that I want to dig a bit deeper into. And I'm not sure if you've ever seen an MRI of a baby suckling at the boob. Have you ever seen it?
I don't think so, no.
Well, after this podcast, honestly, YouTube it, because it's absolutely fascinating. Because when a baby suckles on the boob, it creates a seal around the nipple. So no air is visible, and it essentially creates a vacuum that's maintained throughout breastfeeding. And that's really worth noting because that is what's intended by nature. But in reality, what's happening is mothers are pumping their milk, storing their milk, freezing their milk, and all of that eases a lot of the difficulty that comes with breastfeeding. And this should absolutely be done to prolong breastfeeding as much as we can. But literature and our own research have shown that when there is air exposed to breast milk, these essential components like the microbiome, the anaerobic bacteria like bifidobacterium, they are completely destroyed. Same thing happens during the freeze-thawing cycles. And if you actually look at the literature, this is in line with studies that we have available showing that pumped milk differs in microbiome composition compared to naturally expressed, or how babies who receive pumped milk are more likely to have respiratory infections or become obese. But nobody's really put two and two together here and really understood that that is the impact of oxygen when milk is being stored and being pumped. And, I'm not here to discourage women from pumping or storing milk in any way, but there is a need to think about innovative methods to really maintain these components during those processes.
And you mentioned there was also some loss of potential bacteria during the freezing thawing stages as well. And so if there was pumped breast milk stored in a way, what are the kind of ideal ways to store it to ensure minimal loss of beneficial bacteria within those breast milk samples?
Yeah, so ideally it would be keeping it in the fridge. But of course, at the moment, we can't keep milk in the fridge more than 7 days. Every country has a different sort of regulation and rules. But if we can think of ways that we can keep that breast milk in the fridge for longer, avoiding those freeze-thaw cycles, it's going to be a game changer.
And I guess there's more sort of talk now on social media about colostrum as well. What are the specific benefits of that to the baby itself? And is there sort of anything mothers can do specifically to, make sure that the potential of that is, I guess, maximized?
Yeah, so of course, colostrum is the first milk that's being produced by the mothers, and it's made in a really small amount. It's high in protein, it's low in fat, it has a microbiome. It also has these immunological factors, your IgA, your lactoferrin, but also growth factors. And so I've seen a lot of things online as well, as you said, of women sort of harvesting colostrum. And I actually think that's a really valuable thing to do if you can, particularly because it allows you to get to know your breasts a little bit better. So when it comes to breastfeeding, you can almost hit the ground running. Also, if you have pre-existing diabetes or gestational diabetes, the content of that colostrum can really help maintain the sugar levels of your infant. Another example is, of course, if you have a planned C-section, having that stash could be really useful if it takes a while for your milk to come in. Interestingly, in some cases, you are told not to. That reason being, when you express or trying to harvest colostrum, you do produce oxytocin, which is, of course, the same hormone that can start contractions. So if you do have any history of, preterm birth, you're advised not to. But other than that, I think it's a really sort of interesting thing to do that could really help you down the line.
Now, we've, I guess, mentioned all these benefits of breast milk to the infant, but what is the advantage, if any, of breastfeeding to the mother themselves?
Yeah, so there's a lot of studies on this showing how there's even been a reduction in things like breast cancer as well. But beyond those sort of clinical indications, there's a lot that shows it can help with postpartum depression, can help relieve stress. So really, you're not only giving your baby a benefit here, you're also helping yourself.
You mentioned there that specifically about the loss of these anaerobic bacteria when a mother is pumping the milk. And I think your company, BoobyBiome, is involved in manufacturing a device which can maintain that vacuum seal almost, and keep some parity with what's happening in the natural world where there is that complete seal. What would you want to see in the future of this breast milk space, both in devices, but also in the manufacturing side of formulas, and I guess trying to evolve the science a bit more so we can get better quality, better standards, and improvements in, these products that are there?
Definitely. So you're right. We have two products coming to market, two very different products, but both delivering a breast milk microbiome to every baby. And that first product you mentioned is a device that could be used by parents, also in healthcare settings, that can really preserve that breast milk microbiome by essentially mimicking the conditions that you'd find in the gut or in the mammary gland. And so with our device, we've seen that we can increase the viability of bifidobacterium. We've seen that we can maintain the antioxidant content in milk. We can prevent the growth of harmful bacteria when it's stored. And we can actually also extend the shelf life of the milk as well. And so we are really excited. I think excited is an understatement there, to really see this being used in the hands of mothers and healthcare professionals. But, when it comes to available products out there for parents who do breastfeed or don't breastfeed, I think regulation is a really important one. I've already sort of touched on earlier how the infant probiotic space is like a wild, wild west. It's completely unregulated. One of the reasons for that is you can put a strain of bacteria on the market without showing any clinical efficacy whatsoever. You only have to show it's safe. And as a consequence of that, hundreds and hundreds of companies or infant probiotics have applied to EFSA, which is the European Food Supplement Regulators, for what we call a health claim, which shows, does your product work? And every single company has been rejected from a health claim. And that's really disappointing to see. I am going to caveat that and say some of these infant probiotics are better than others. There was a really good study done with the probiotic Labinic in necrotizing enterocolitis in preterm infants, where we actually saw a reduction in NEC. But the thing is, there's no way to show which is a probiotic that's scientifically validated and which isn't. And that makes it really difficult for parents when they walk into Holland & Barrett's and they've got a selection of 20 probiotics to choose from, and it's already overwhelming. And so I would love to see things being better regulated, better standards, and I think that could really change the health, but also make things a lot better for parents.
We discussed earlier about this crucial window for microbiome development. We sort of said that, we don't know really quite how long it is, but it's likely shorter than we realize and maybe even earlier than we realized. So in adults, if you improve your diet and improve your lifestyle behaviors, you can improve your microbiome, certainly the diversity of bacteria, and feel better for all intents and purposes. Even though, you can't completely revolutionize your microbiome, there is a lot of flexibility and malleability, even at an adult stage. So as a child, as an infant who has maybe been subjected to antibiotics, maybe been, born by C-section, had, preterm births, various other modifiable and non-modifiable factors which have resulted in a potentially dysbiotic microbiome, that's not necessarily a fixed issue. And so that's it. It cannot be changed anymore. And so how quickly can that change into something that leaves away the dysbiosis and goes into something beneficial? How can that be changed and how quickly can that be changed?
So that will just vary from person to person, right? What we've not really spoken about here is how our microbiomes are completely personalized to ourselves. And so what could happen to one person could be completely different to another person. And so that's really difficult to quantify. But what I will say is that in some scenarios, you will get a baby that is born preterm or born by C-section, has chronic antibiotic usage, was not breastfed and formula fed, and they will be absolutely fine. And why is that, right? And I find that almost the most fascinating aspect of microbiome science, because what we need to remember is all of these are risk factors. It doesn't mean if you're born by C-section, you're going to get asthma by the age of 5. It doesn't mean if you're formula fed, you're going to have allergies. And so I think we really need to understand sort of beyond the microbiome, what is actually happening here? What is the link between our genetics and our microbiome? The metabolites, everything put together. And I think that's going to require lots of expensive multi-omics research, but that's also longitudinal. And at the moment, there's just not enough funding to be able to do that so that we can have a solid answer.
Yeah, I agree. I mean, there are millions and millions of people who are born via C-section and who are grown up to live very healthy, very normal lives, as you said, without any disease states at all. And likely there will also be children who have been breastfed and been born vaginally and had all the right factors, but also can become very unwell with chronic autoimmune conditions. So I guess, we can't be focusing on that too much. But do you see a future where, if we consider breast milk to be one of the most scientifically validated forms of personalized nutrition out there, do you see a future where we can have infant formula as personalized nutrition, where it's almost akin to breast milk? So there is no difference or worry in anyone concerned about not being able to breastfeed versus only having infant formula.
I don't think we will ever be able to replicate breast milk. I think it's absolutely impossible. I think, there are ways that we can replicate aspects of it. It's exactly what we're doing, replicating the microbiome aspects of it. There's really interesting companies in the US who are, you mentioned this earlier, who are essentially using mammary gland cells to express milk. And again, that's an interesting avenue. I think it will take millions and millions of dollars and years of manufacturing and scale up to have that ready on the market. But again, that's only another aspect of breast milk. That's the nutritional aspect. They're not developing the microbiome in that sense. And so I don't think we will ever be able to get a formula milk that can mimic breast milk. But, all these things are helping for when breast milk isn't available, because, as I said, we can definitely improve existing formula that's on the market.
So when a mother breastfeeds a baby, there's obviously some bidirectional crosstalk between the mother sending signals to the baby and then the baby also sending signals via saliva to the mother. And that's part of the customization process of the milk. Suppose, thinking back to the 50s and beyond, where there's an increasing abundance of wet nurses, where a mother would let another woman breastfeed her child. What would be the impact of that, given that the genetics of the other person and the baby are different? And I guess there has to be some significant difference between you breastfeeding your own baby versus someone else breastfeeding your baby, surely.
Yeah, definitely. So I mentioned earlier, this question, where does breast milk bacteria come from? And I spoke about one option, which is the translocation from the gut. But other people argue that it's this retrograde flow, right? So the bacteria in the baby's mouth will essentially re-inoculate back into the breast milk microbiome. And so you can imagine, if you've got lots of different women feeding the same baby, that's going to result in a really, really diverse microbiome. Sort of parallel to that, I read a really interesting paper recently that basically looked at, why is it that male and female have everything set up to breastfeed, but it's only the female that does? And it was a really interesting paper that basically modeled how, if you had both parents breastfeeding, you're actually going to be introducing more pathogenic bacteria into the breast milk microbiome of that baby or of that sort of offspring. And so this paper was actually arguing that this is something that we've evolved with, that only one parent from that sort of couple can breastfeed for that reason. So I imagine that, yes, it's great that you're going to be diversing the microbiome, but you are risking more pathogens entering that infant gut. And what's quite interesting about infant guts are they're not as diverse as adult ones. So ideally, you want them to be sort of high in abundance in one type of genre, which is bifidobacterium. You don't want them to be as diverse as what you'd expect in an adult. And so that is the risk that you might be having there by using multiple sort of wet nurses.
What about the health of the mother? If the mother has pre-existing comorbidities and other health conditions and their own gut health is suffering, I know we mentioned there are maternal factors which can impact breast milk quality, but can it impact the breast milk to the degree where it can have negative impacts? And maybe there's, complete dysbiosis in the mother's own gut bacteria, which can then be passed on via breast milk to the baby? Is there cases like that in which maybe breast milk and breastfeeding could be harmful and actually infant formula or some other alternatives may be more beneficial?
Absolutely not. So it's really interesting. We're going back to this theory of gut translocation, right? And we have sampled hundreds and hundreds and hundreds of women's breast milk. And it's very rarely that we see a potentially pathogenic bacteria turning up. And it goes back into this question, well, is gut translocation a selective process? Are we selecting the beneficial bacteria in the gut? And are those the one that's translocating into the breast? We don't know the answer to that question. So there would never be a scenario where breastfeeding can cause any harm. There are factors that can, make your breast milk microbiome better. So when as I said, we've collected samples from lots of women. We've also collected the infant stool sample so that we can understand which strains in the breast milk microbiome are actually colonizing the infant gut. And so during that process, we get all of our mothers to undergo an extensive questionnaire where we talk about how old is she, her diet, where does she live, is she a school teacher? We've actually seen that as one of the factors that can actually let you have a really diverse breast milk microbiome, weirdly, probably because you're surrounded by children every day. And so, we've identified some women being super donors, those super donors being defined as women who have high abundance of bifidobacterium. Other women will have much less bifidobacterium, and we've identified factors that can contribute to that. But at the end of the day, breast milk will always be better than formula milk because of, how it's not just got this microbiome, but it also has these immune protecting factors, as I mentioned, like the immune cells, the lactoferrin, the proteins, etc.
Thanks again to Sioned Jones. Next episode, we'll be discussing nutrition scams, health myths, and the problem with diet hacks with Dr. Nicola Guess, nutrition scientist at the University of Oxford. Subscribe so you don't miss that and the weekly Dr. Karan Explores podcast. I'll see you walking microbiomes next week.